Okay, magandang araw po. Okay, so for today, we will be solving problems regarding deflection using double integration method. Okay, for this problem, we are required to compute the EIY, or the product of modulus of rigidity and deflection at the right end of the overhanging beam shown below. So this is the overhanging part of our beam. So first one, para ma-solve natin yun, is to solve first for the reactions at the support. So i-draw lang natin yung free body diagram natin. So roller support, meron tayo isang reaction doon. Make that as reaction at A. 1,000 pounds. And then hinge support, isang reaction at point B. And then rectangular load na 400 pounds per foot. Yung reaction sa point B natin, meron tayong horizontal doon. But then walang magka-counteract na another horizontal forces doon. Therefore, that will be equivalent to 0. So hindi na natin siya kinonsider. 6 feet, 4 feet, 3 feet. Point A, point B. Okay, kunin natin si reaction at A first. We will take summation at moment at point B, equivalent to 0. Clockwise motion is positive. RA, papunta kay point B, ang galaw, clockwise. So that is positive. RA multiplied by a perpendicular distance from that point to this point. So a total of 10 feet. 1,000, papunta kay point B ang galaw, is counterclockwise motion. So minus 1,000 multiplied by perpendicular distance of from this point to this point, that is 4 feet. And then 400 pounds, papunta kay point B. Ang galaw ay clockwise motion, positive yun, plus 400 times 3. And then, yung centroid, nag-aak sa gitna ng base, which is 3. Kalahati na 3 ay 1.5, papunta kay point B, is also 1.5. And that is equivalent to 0. So, solving for reaction at point A, calculator nyo lang po yun, guys. That will be equivalent to 220 pounds. And then, para makuha yung reaction at point B, we will take summation at moment at point A. Summation of moment at point A, taking clockwise motion is positive. Okay, take natin moment. RB, papunta kay point A, ang galaw, clockwise motion. So that is negative. RB multiplied by perpendicular distance, a total of 10 feet. 1,000, papunta kay point A, ang galaw ay clockwise motion, positive. Multiplied by 6. 400, papunta kay point A, clockwise also, plus 400 times 3. Analyze natin yung perpendicular distance. So, gaya kanina, nandito yung concentrated load, yung rectangular load natin. Mag-aksa, gitna, kalahati ng 3. 1.5. Pero ang perpendicular distance, papunta kay point A. So, 1.5 plus 10, that is 11.5, equivalent to 0. So, solving for reaction at point B, we will get a value of 1,980 pounds. So, i-check natin. Checking, we will take summation of forces along vertical axis equivalent to 0. So, upward, RA at saka RB, 220 plus 1,980 pounds. Downward, minus 1,000. downward din yung rectangular natin. So, minus 400 times 3. Equivalent sa 0. So, dapat mag-equal sa 0 yan para maging tama yung reactions na nakuha natin. And that will be equivalent to 0. So, 220 is correct. 1,980 pounds is also correct. Okay, since nakuha na natin yung reactions natin sa support at point A at point B, lagay lang natin dito. RA is 220 pounds. RB is 1,980 pounds. Since nakuha na natin mismo, next thing to do is to analyze the unknown. Pinapakompute mismo yung deflection at this part, sa right end ng overhang beam. So, para makuha natin yung Y or deflection dito, isi-section lang natin mismo yung overhang part natin, overhang beam natin. So, pag hinati natin dyan, dalawa po yung section na mako-consider, o dalawa po yung section na magagawa natin, left side section and then right side section. Ang i-consider lang po natin yung nasa left side para makonsider natin yung iba pang reactions. So, kung i-redraw natin, po, rectangular loop, and then 1,000 pounds per foot yun. 6 feet, 4 feet, 3 feet. At this point, papunta doon is X. Hindi natin alam kung saan natin siya section. So, hindi natin alam kung malapit kay BB, punta doon. So, let's assume that is a distance of X. Ito naman isang section natin. Sa right side. 400 pounds per foot. So, hindi natin i-consider yan. Ito i-consider lang natin. So, we know that EI Y double prime is our moment for our double integration. So, na-discuss na yan. So, para ma-compute mismo yung ating deflection, this is our moment equation. Para ma-compute mismo yung deflection, yung y double prime, from the topic itself, double integration. Para ma-compute natin yung deflection y, dalawang beses lang po tayong mag-integrate. Dahil pag integrate natin si y double prime, y prime yun. Pag integrate natin si y prime, that is y. So, double integration. Yung y prime, sa mathematics, pag sinabing y prime, that is the slope. So, pag naging y prime yan, integrate natin yung moment, slope equation po yun. Susunod. Yung slope equation na y prime, pag integrate po natin y, yun yung deflection equation na tinatawag. So, para ma-compute natin yun, compute first the moment. So, yung moment na yun, paano makukuha? Since hinati natin mismo yung beam natin sa part na to. Pag hinahati mismo yung mga structural part, meron tayong lumalabas na forces doon. So, since moment yung kukulin natin, analyze natin yung nasa moment. Yung moment na pupunta dyan is counterclockwise dahil yun yung kanyang positive direction. Okay, so para makuha mismo yun, yung moment na yan, we will just take summation of moment at this point. So, taking summation of moment at this section part equivalent to 0, clockwise motion is positive. Yung 220 papunta kay section part, that is clockwise. So, that is positive multiplied by perpendicular distance from this point to this point, that is X. Yung 1,980 papunta sa part na yon is clockwise also. Ano perpendicular distance from this point to this point? Sorry. Ito hindi siya 3 feet. 3 feet kapag kasali to. Dahil na section po natin. Okay. So, hindi natin alam kung ano yung part na yun. So, 1,980, yung kanyang perpendicular distance from this point to this point. Ano yung distance na yun? Ito ay X. So, para makuha yun, minus lang natin to. Ang perpendicular distance na to, this is x minus 10. So, this is x minus 10. Yung 1,000 naman, papunta sa section part natin, counterclockwise yun, negative moment, multiplied by perpendicular distance from this point to this point. So, ano yun? X minus this distance. X minus 6. Next one, yung rectangular load. Papunta kay section part, counterclockwise. Minus 400 times the base. X minus 10. Yung kanyang perpendicular distance. Yung concentrated load po natin, nag-act sa gitna or centroid ng rectangular area. So, kalahati ng base, kalahati ng x minus 10. X minus 10 over 2 equivalent to hindi pa, meron tayong moment doon counterclockwise, minus m equivalent to 0. Ito na yung kinukuha natin. Computing for m, magiging positive doon, lipat lang natin. M will be equivalent to 220x minus 1980 x minus 10 minus 1000 x minus 6 minus, simplify natin to, 200 x minus 10 squared. So, substituting sa ating equation, EI y double prime is equivalent to 220x 1980. So, therefore natin nun minus x minus 6 minus x minus 10 quantity squared. Okay, so integrating both sides of the equation. Pag integrate natin ulit, then ay slope equation na. So, EI, this is constant. Wala lang pong value na binigay sa problem natin. Pero pag may value, madidivide lang po yan mamaya. Kung merong value. Since wala, nakamultiply lang siya kay y values. So, integrating y double prime, y prime, or slope, equivalent to, integrating 220x, 220, integrating x is x squared over 2. Power formula lang po. And then plus, 1980, integrating x minus 10, again, power formula. So, alam nyo na yan sa integral calculus. Minus 1000, x minus 6, squared over 2, minus 200, integrating x minus 10 squared, power formula again, raised to 3 over 3. Pag nag-integrate po tayo, don't forget the constant term, plus C1. Okay. Pangalawang integration, integrate both sides. EI, magiging y na siya. So that is 220, 110 na lang yun. Integrating x squared, x cubed over 3 plus 1980 divided by 2, 990. Integrating x minus 10 squared, x minus 10 raised to 3 over 3 minus 500 na lang yan. Integrate ngayon, power formula ulit, x minus 6 raised to 3 over 3 minus 200. X minus 10, magiging raised to 4 na siya over 3 times 4, 12. Integrate natin si C1 plus C1x plus, don't forget the constant term, C2. And that will be our deflection equation. Okay, nakuha na natin yung deflection equation natin. Ito na siya. So, next thing to do is, kunin natin yung values ng constant C1 and constant C2. So, para makuha natin yun, analyze natin yung deflection form ng ating beam. Kunin natin ulit yung beam natin. Ito yun. Yan. Ito yung beam natin. So, analyze natin kung paano daw made-deform o made-deflect yung ating beam. So, kung i-analyze natin, ganyan po yung form niya. So, habang gumigit na, Since mas bumibigat yung load doon, nandito yung concentration ng load natin, doon malaki yung deflection Y. Then sa overhang part natin, sa right end, ito yung kinukuha. Malaki din yung value ng Y natin. Okay, pero sa support natin at point A and at point B, since may support doon, yung deflection natin kung papansin nyo ay 0. Since may supporta hindi masyadong magde-deflect sa part na yun. No? So, kung i-analyze natin yung point A, daming aso. Okay, at point A, ano ba yung value ng x natin sa point A? Ito yung point A natin. Yung value ng x natin, wala pa. Dito pa lang tayo hindi tayo nag-start ng value ng x. So, at point A, ang x natin ay 0. And sa part na yun, ang deflection natin, which is y, is also 0. So, meron tayong value ng x tsaka y. Isusubstitute lang po natin yan sa ating deflection equation. Okay, substituting EI, y is 0, maging 0 to, equivalent to, eto, maging 0 plus 990 over 3 is 330. 0 minus 10 raised to 3 minus 500. 0 minus 6 raised to 3 over 3 minus 200. 0 minus 10 raised to 4 over 12 plus C1 times 0. 0 plus C2. So, makukuha na natin value ng C2. Calculator lang yan guys, and you will get C2 equivalent to 0. Okay, meron tayong C2. Analyze natin ulit yung deflection form natin. At point B, ito yung point B natin. Ano yung x natin doon? From this point to this point. Ang x ay total of 10 feet. So, at point B, x equivalent to 10 feet. Ang deflection natin ay wala sa point B. Since may support, deflection is 0. So, may value tayo ulit ng x tsaka y. Substitute lang natin yan sa ating deflection equation. So, EI times y, that is 0. 110, x is 10, is 3. Eto, 10 minus 10, 0 yun. Minus 500. 10 minus 6, raised to 3 over 3. Eto, 10 minus 10, so maging 0 yun, plus C1 times x, x is 10, ang C2 ay 0. So, computing for C1, calculator lang yun guys, you will get a value of negative 2,600. So, nakuha na natin yung values ng constant natin. I-substitute lang natin yung C1, C2 values natin. Therefore, EI, y is equivalent to 110x cubed over 3. Ang 990 over 3 ay 330. X minus 10 raised to 3 minus 500. X minus 6 raised to 3 minus 200. X minus 10 raised to 4 over 12 plus C1x. Ano ang C1 natin ulit? Negative. So, minus 2,600x plus C2. Ang C2 natin ay 0. So, wala nang 0 yun. So, wala din natin lalagay. And that will be our deflection equation. Yan na mismo. So, para makuha natin mismo yung deflection natin, ang pinapakuha kanina, deflection daw sa overhang part. Sa overhang part natin, ang x natin ay a total of 13. So, para makuha yung y dyan, substitute natin x equivalent to 13. So, at x equivalent to 13 feet, what will be the value of y? So, substitute lang natin. So, substituting EI, y is equivalent to 110, x is 13 raised to 3 over 3 plus 330, 13 minus 10 raised to 3 minus 500, 13 minus 6 raised to 3 over 3 minus 200. 13 minus 10 raised to 4 over 12 minus 2,600 times 13. So, calculator na lang yun, guys. Enter this equation as is sa calculator. So, EI, Y is equivalent to negative 2,850 pounds feet cube. And that will be the requirement